Hello my friends, Sailesh sir here. Today we are going to discuss the second part of your chapter Force and Laws of Motion from class 9. In last part we have discussed about the force and its types. Now here we will discuss 3 points. First is inertia, second is momentum, and third point is these 3 laws of motion. Most important part is these 3 laws of motion given by scientist Newton, Mr. Newton. He gave these 3 wonderful laws. They are known as base of the science, basic concept of the science, physics. They are very important. But before this discussion of these 3 laws, we have to remember these 3 words. One is force, second one is this inertia, and third one is momentum. Force already we have discussed. Briefly I am telling the pushing or pulling of an object by applying some external energy is known as force. So it means to change the position of the object we must apply the force. Force is nothing, the amount of energy given to the object, that is known as force. So force is the result of energy, mind well, and energy is the main cause of the force, which gives us the amount of energy is the main cause of force. So cause of the force is energy and force is the result of energy. Clear? Now the second 2 words, they are, first one is inertia and second one is momentum. So let us see what is inertia. This word is given by a scientist, Galileo. His full name was Galileo Galilei. He was an astronomer. Okay. So you have to remember just what Galileo. So he gave this word inertia. According to him, he said that any object of the world will try to remain in the same position because they have got, every object has got the natural tendency to resist to change its position of motion or rest. Clear? So according to him, if any object is in rest, it will try to remain in rest, because it has the natural tendency to resist to change its position. And any object in the motion will try to keep in the motion because it has got the natural tendency to resist to change its position, so it will continue to move, and object in rest will remain in rest due to this resistance power, natural resistance given to the object. They will try to maintain their original position. They don't want to change the position until any external force is applied on it, more than its resistance, more than their natural resistance. Then only they will move. If we apply less force than their natural resistance, they will not move. This is clear concept. Okay. Again, what is inertia? A scientific way, in simple language, every object has the natural tendency to resist or oppose to change their position by itself is known as, this property of object is known as inertia. Clear? It means that to make the object change its position or make them move or stop, we must apply the force more than their natural resistance. Clear? Okay, this was the concept given by Mr. Galileo. On the same concept, Newton gave is first law of motion, and second law of motion is given on the second word, momentum. So first, what is momentum? So what is momentum? So momentum, there are so many forms of speed, types of speed. Basically all are speed. One is speed itself, second is velocity, that is also speed. Acceleration, that is also fundamentally, that is also speed. So speed is got these 3 forms: speed, velocity, and acceleration. Speed, without direction. object is going without any definite direction. Velocity means object is going with the speed with definite direction, in the definite direction. That is the speed with direction. So normal speed is, direction is not mentioned. And acceleration means changing speed or changing velocity, because velocity and speed fundamentally same. Changing velocity is acceleration. Clear? So here, what is momentum? Force. That is also speed. Wow. What? How? So that is also speed. I am explaining. Now you know velocity is the speed with direction. Now I am adding another one, mass. If I consider the mass, so you have to object which is heavy. Mass means weight, kind of weight. The heavy object, we have to apply more force to get the speed, more speed. And for light object, we have to give less energy or less force to make them move, make them in velocity. Clear? That's the common sense. Heavy object will require more force and light object will require less force to get the speed. So here, this instead of speed, the word is velocity is given. You know, velocity is the speed with definite direction. So what is momentum? It is the speed or velocity with respect to mass. Mass means more, with more mass means more heavy, and less mass means less heavy. Clear? So the final definition, scientific definition of the simplest definition of velocity is a product of this momentum. So momentum is a product of mass and velocity. What is product means? Multiplication, mass into velocity. Okay. So again, what is momentum in scientific language? Product of mass and velocity is known as momentum. Okay. For momentum, they have given the symbol P in physics. For mass, m is given, and for velocity, v is given. So momentum P equal to mass m into velocity v. That is P equal to m into v. But you have to remember in the word, then you can put the symbol. You can put the symbol easily. Okay. So momentum is a product of mass and velocity, means momentum is a multiplication of mass into velocity. Clear? So this is the definition. Momentum equal to mass into velocity, and the momentum is symbolized by P, mind well, not by M. M stands for mass and P stands for this momentum, and V stands for velocity. Okay, clear? So after understanding, momentum is a type of speed, as I told you, with respect to mass. More this force, momentum will be more, and if we give less force, then momentum will be less. This is the fundamental of speed. That is momentum, depending on mass. So the heavy vehicle will require more force to get the speed, and this light vehicle, light in weight, light in mass, with low mass, they will require less force. Clear? Now we will understand the three laws of motion one by one, depending on these three words. All are interconnected: force, this inertia, and momentum. So first definition is based on the word inertia, given by Mr. Galileo. It is the refined form of this inertia definition. So what is first law, given by Mr. Newton? First law of motion, mind well, first law of motion, that is known as Newton's first law of motion. So I am starting here. Any object cannot change its position by itself, whether it is in rest or in motion, until any external force is applied on it. Clear? That is the same cousin definition of the inertia. In inertia, we were adding only one word: resist. Register. Every body resists to change its position. Here we don't have to use the word resist. to resist, tendency to resist the position. Here we have to, if we use the word resist, then it will become the definition of this inertia. And if you remove the word resist, natural tendency to resist, then it will become the first law of motion given by Newton. So again, what is first law of motion? Any object cannot change its position of rest or motion by itself until any external force is not applied on it. Means if external force is not given, that only given, if it is given, then only they can change the position. If external force is not given, they can't change. So what is first law of motion? No object can change its position of rest or motion by itself until any external force is not applied on it. Until we don't give the force, they will not move. When we give the force, they will move. That is the cousin definition of inertia. They are telling the same thing. Every object has the natural tendency to oppose, to resist the change its position. They also can't change by itself. Only they can be changed by the force given to it, more than that resistance. Clear? Difference in inertia and this first definition is very of the one word only, resistance, natural tendency of resistance. Other things are same. That is the reform form of inertia. That is first law of motion. Fundamentally, both are conveying the same message, same thing. Okay. So now second law. That is depending on the second word, momentum. We have discussed. What is momentum? That we know. That is the type of kind of speed with respect to mass, velocity with respect to mass, and the mass into velocity. Okay. So this speed can be changed by the force. More the force, this momentum will be more, and less the force, so momentum will be less. So it depends, this momentum, the speed that is referred to momentum is depending totally on the quantity of force, how much force you apply, and also they are depends on the mass. More the mass, you will require more force, and less the mass, you will require less force to move it. Common sense. Heavy vehicle will require more force to move, and these light vehicles will require less force to move. They are proportional to the force. The same thing is said in the second law of motion. So second law of motion given by Newton says that, second law I am starting. The rate of change of momentum is proportional to the force applied on it. The rate of change of momentum, that is change of velocity, is proportional to the force applied on it. Clear? But with respect to mass. Here we are considering their mass. Momentum consider mass. If we remove mass, it becomes velocity. And if we add mass, then the same velocity is converted into the word momentum. Clear? This is the fundamental. Again, the rate of change of momentum, that is, velocity, one type of velocity. The rate of change of momentum is proportional to the force applied on it. This is the definition. Velocity is also speed, and momentum is also a speed. That type of speed, changing speed. Changing momentum means changing speed or changing velocity. Both are same fundamentally. All the three things are speed only. And this speed, to get the speed, we require force. More the force, more speed. Less the force, less speed. Common sense. That is proportional to this applied force. So rate of change of momentum is directly proportional to the applied force, or proportional to the applied force. That's the definition or law that is known as second law of motion. Clear? Now, the last law of this motion, that is third law of motion given by Newton. So what is the third law of motion? Definition is the most simple definition and the most easy definition to remember. So Newton gave the third law like this: action and reaction of two objects are always same and in opposite directions. Action and reactions are always same and in opposite direction. This is the law, very simple. Action and reactions are same but in opposite direction. What is the examples? Take a tennis ball and strike on the wall. It will come back in opposite direction. That is opposite direction. Reaction is in opposite direction. Action, more the force you strike, it will come back with the more force. And less the force you strike your tennis ball, it will come back with the less force. That is, action and reactions are always equal and in opposite direction. Clear? By this example of this striking tennis ball on the wall. Action when you strike and reaction when it comes back. That is the fundamental laws of universe. What we call call in the general term, in the world. Okay, so Newton Baba, Mr. Newton means scientist Newton, gave these three laws one by one. I will speak briefly. The first law of Newton: no object can change its position by itself until any external force is not applied on it. Clear? Without force, they can't change the position. It means with force they can change the position. Clear? Now, the second law of motion: the rate of change of momentum is proportional to the applied force. More the force is applied, more momentum means more speed or more velocity. And less the force is applied, then less speed or less velocity or less momentum. All are basically speed, mind well. But here momentum we refer to mass, because momentum equal to mass into velocity. Momentum, that type of speed with this mass. More the heavier car or a heavier vehicle will require more force to get the speed, and lighter vehicle like the scooter or your bike will require less force to move. Common sense. That fact is said in this second law. Rate of change of momentum, that is change of speed or velocity, is directly proportional to the force. More the force, more speed, more velocity, more momentum, and less the force, that will be less momentum, less velocity, less speed. Common sense. Don't get confused. Basically, remember all these words are speed in your mind, but different form with little change. Clear? Now, the third law: action and reactions are always equal and in opposite direction. Example, striking this tennis ball on the wall, it will come back in opposite direction. That's why it is written in opposite direction. And more the speed, with more force, if you strike, it will come with more speed, more force. And with less force, if you strike, then this ball will come with less speed. That is action. And reaction are always equal. And in opposite direction, it must come back. Reaction must be in opposite direction. That was all about these three laws of motion by Mr. Newton. That's all for today for this chapter. Good night.